Welcome, my friends, everyone. Today, we're going to dive into the fascinating world of virology by exploring the basic structure of viruses. We'll start by understanding that at the most fundamental level. You should know to know general properties of virus, to describe viral structure, to know the pathogenesis of viral infections.
Hey there, human. Long time no see. Or should I say long time, no infection?
Oh, great. Just what I needed. Another virus trying to invade my cells. Can't you guys just give it a rest?
Oh, come on. I thought you'd be happy to see me. We viruses have to make a living too, you know. It's nothing personal.
Viruses are smaller than all infectious agents. Viruses have sizes that vary from 10–300 nanomet. The genome of viruses may be either DNA or RNA. Viruses have no metabolic activity outside susceptible host cells. They are obligatory intracellular. They do not possess any ribosomes or protein synthesis apparatus. Viruses are only seen by electron microscopes. The genome of viruses may be either DNA or RNA. Viruses have no metabolic activity outside susceptible host cells. They required living cell, cannot grow on culture media. Extracellular virus is metabolically inert. I'm always finding new ways to sneak past your defenses. You've got to admit, it's kind of impressive.
What capsid is it? I know. The capsid consists of protein units, capsomeres that are made of protomers, arranged around the nucleic acid in different ways. Functions of capsid. It protects the viral genome from inactivation by environmental factors. It facilitates attachment to host cells. It's responsible for viral symmetry. It's antigenic and specific for each virus type, responsible for immune response because capsid is immunogen. I know your envelope. It is an outer layer of lipid or lipoprotein that surrounded some viruses. Viral glycoprotein spikes arise from the surface envelope. Function of envelope: add protection of the virus. It helps the virion to enter host cells by fusion or attachment with the cell membrane. Add antigenicity to virions. Nucleic acid carries the genetic information that consider the infective part of virus. Virion is a complete virus particle. Nucleic acid, protein coat, envelope. What is the type of nucleic acid?
We classified the viruses according to nucleic acid type, to DNA, RNA, and segmented RNA. Properties related to classification: all DNA are icosahedral cubical, except poxviruses. All DNA is double-stranded, except parvovirus. All RNA is single-stranded, except Reoviridae. All RNA are helical except Picornaviridae, Flaviviridae, Togaviridae, Reoviridae.
We classified viruses according to viral symmetry to icosahedral, helical, and complex. Complex virus, such as bacteriophage. We classified viruses according to viral presence of envelope to enveloped viruses and non-enveloped viruses. How about you take credit for the fevers, coughs, and endless sneezing fits instead? Let me talking about mode of transmission.
Pathogenesis of viral infection. Routes of viral entry. 1. Gastrointestinal tract. Viruses acquired by ingestion, by swallowing or infecting cell in the oropharynx, and then carried to the intestinal tract. 2. Skin. Inoculation by skin abrasion, or arthropod vector, or blood transfusion, or contaminated needle. 3. Genital tract. Herpes virus, human papillomavirus, hepatitis C, B viruses. 4. Respiratory route. The most important entry site of viruses.
Oh, how are you spreading?
Mechanisms of viral spread. Localized infection. Virus invades only adjacent to the site of entry. Incubation period is short. Immunity is short. Systemic infection. Virus migrate from the site of entry to the lymph node and blood, causing viremia. From the bloodstream reaches its target organ: skin, liver, Incubation period is long. Immunity is long-lasting. Pattern of viral infection. Acute infections. Virus usually does not persist in the host. After recovery, persistent infection. Latent infections, in which infectious virus is not demonstrated, and disease is usually absent, except when reactivation of virus occurs. Chronic infections, in which infectious virus is always demonstrable and often shed, and show symptoms and signs all the time. Slow infections, in which infectious virus gradually increases during a very long preclinical phase, leading to a slowly progressive lethal disease. Common characteristic of viruses that cause persistent infections. They evade the immune system. Transforming infection. The integration of a virus genome into a cellular genome may lead to alteration of cell morphology, leading to the cell changing from a normal cell to a malignant cell.
Effect of chemical agents on viruses. Cloax and formaldehyde can kill enveloped and non-enveloped viruses, where phenol, glycerol, and antibiotics cannot kill either enveloped or non-enveloped viruses, but detergents and alcohol can kill enveloped viruses only. Effect of physical agents on viruses. Radiation, cold, and heating 50,000 60 degrees for 30 minutes can kill enveloped and non-enveloped viruses. I hope today's discussion has sparked your curiosity and provided you with a solid foundation to build upon in our future sessions. Thank you once again for your participation, and I look forward to our next lecture, where we'll delve even deeper into the fascinating world of viruses. Have a great day. Thank you for watching. Viruses, we'll be ready for you every time. Thank you, my colleagues.